Hello everyone, so I'm Bala. Some of you might have seen me present in a couple of the few wireless field days that we've been part of. Been with Aruba for about 5 years now. I'm a product manager. I own the voice, video, UCC, and air group real-time kind of applications on the Aruba side of the world. So the answer to the question that somebody asked about how long did it take to enforce Lync? The answer to that is one day morning I come back to my cube, I don't find my hardwired phone. I just found a nice Plantronics Bluetooth headset in my cube. So it was definitely forced, but that is a trend that we are also seeing in our customer base as well, right? Because it's kind of unavoidable because BYOD is here, people are all spending most of the time on their mobile devices, smartphones, tablets, whatever. Now, why do we need an additional hardwired phone? Why can't we also do the same voice-based communication using a soft client that's running on the mobile device that I use for everything else that I do, right? But obviously, the challenges are many, which we are all quite aware of. There are challenges on the client side. There are challenges on the Wi-Fi side. There are challenges on the wired side. End-to-end quality of service. Clients don't do any kind of upstream QoS tagging today. We completely depend on each client's operating system, each client's chipset to do any kind of QoS today, right? So there's a lot of heterogeneity when it comes to identifying traffic, when it comes to applying the right kind of policies. And beyond that, the other challenge that we have with Wi-Fi is obviously people are all on their mobile devices. They're using UCC. The biggest scare that all the administrators have is give me some visibility. What is going on in the Wi-Fi network? How do I know when there is an issue? And if there is an issue, what is the issue? What is the reason for that issue, right? That was one of the reasons why we worked very closely with Microsoft, who is a customer of ours and who has hundreds of controllers in the deployment. They have thousands of access points. Obviously, they have standardized on Microsoft Lync, and they had the same challenge as well. So we collaboratively kind of sat down and put together and kind of came up. We wanted to come up with a way where we can have the applications program the network, right? That's basically the whole idea. Because of the dynamic nature of these applications, because of the dynamic nature of Wi-Fi. So the changing conditions needs to be fed back from the client that is in charge of an application, in this case Lync, to some kind of a controller, which then talks with the network, right? That's the whole idea. How do we dynamically inform and adjust the network for Lync traffic? Now, the way we do it today is using this SDN API mechanism. So SDN API is something that a lot of vendors are talking about. We were one of the first vendors to collaboratively sit down with Microsoft and develop the metrics that are shared using the API. We are also involved very heavily with Microsoft to define the roadmap of this. So we are glad that we have that opportunity. So what is this API, right? The API is basically it's a plugin architecture. It's basically an executable file that you install on the Lync in one of the Lync components, which I'll talk about, which is basically going to share a lot of good call quality related information, basically information about who's making a call, what quality, what is the call quality that is being experienced by the user, what bandwidth is being used, and so on and so forth, to the wireless LAN infrastructure. As the wireless LAN infrastructure, we take it, we put it on a really nice UCC dashboard so that the network guys now has the visibility to say, Bala is on a call with Rocky on his iPhone, and this is his call quality, right? And he obviously has all the other tools that we provide from RF standpoint to look at what is the TX rates, RX rates, what does the retry look like, interference, so on and so forth. So he can do the correlation and basically say where the issue is. That's the whole idea.
What do you see on? Yeah, we're good now. Sorry.
Perfect. Thanks. Yeah.
Apologize, guys. Sorry.
Hey, Bala, can I ask you a question?
Sure.
It seems that other vendors, and I don't mean to take the focus away from Aruba, but it seems like everybody's first story with SDN is coming across as Lync and Lync optimization and all of that. Does your API, is it the same API that everybody is tapping into, or is there something different about Aruba?
That's a great question. So the API, Microsoft is calling it the SDN API. It's not really using any open for any of the SDN protocols today per se, but there's an evolution path roadmap that Microsoft has. This API is publicly available, is downloadable from Microsoft website. And anybody who has a on-prem Lync infrastructure can install the API. And obviously, the idea is the API knows what network endpoints to talk to, right? So it's going to push the information appropriately. The network infrastructure needs to identify that information and do whatever it is that they do for quality of service, for visibility, and for all the other things that would help them.
We jointly developed it with Microsoft. They're, needless to say, pretty big customer of ours. But it's now available to other infrastructure providers.
Correct.
Is that
the
how it
API
evolved?
is publicly
Does that
available.
answer the question?
Does that answer your question, Lee? Yeah. So we also support for non-SDN API-based deployments. So one of the things that you would have realized is in SDN API, to use SDN API, you need to have an on-prem Lync infrastructure, right? If you have a cloud-based infrastructure, or if you're using some of the other products that we have, like Aruba Instant, which has a more distributed architecture. We also have something called Heuristics that I'll talk about within the next few slides, where we have built in intelligence on the control platform to do DPI, to track user sessions, do some RTP payload analysis, and come up with what kind of Lync session type it is. So jumping right in, from a topology standpoint, this is basically how the Lync UCC infrastructure looks like, right? There are multiple different components. One of the key components here being the Lync front-end server pool. So basically, any client who logs in using his signs into the Lync client has to go through the Lync server pool. This is basically a collection of appliances that takes care of all kind of call setup, all call processing, right? So he knows about who's the user. He knows about who is he trying to call, what kind of session it is, and so on and so forth. Now, this Lync FE, or the front-end server pool, is a bunch of different boxes. In a large network, you can imagine this to be clustered. It's spread across geography so that you have a cluster for each geography, right? If I'm Microsoft, I have a global deployment. I'm going to have a cluster for each region, so that users that are part of that region are able to home in to that particular cluster for any kind of calls that they want to make. The Lync front-end server has two different components. One is called as the LDL, Lync Dialog Listener, and then there is something called as the Lync SDN Manager, right? So you can think of the Lync Dialog Listener as a little process that is running on these devices. Again, this is something that Microsoft provides you from their support side. It's publicly available. Anybody who wants to use this SDN API-based communication with the network endpoints needs to go through this process. So install the Lync, the LDL plugin. Now that talks with the Lync SDN Manager. Now SDN Manager, think of the SDN Manager as an appliance that is in charge of collecting and forwarding information to the network endpoints, right? So user makes a call. This guy knows about it. Now this guy is going to send the information to the SDN Manager. He collects the information, and this guy knows about the network endpoints. So he's basically going to send that information out to the wireless LAN controller where the user is currently terminated, right? Now the wireless LAN controller or other network endpoints appropriately takes that information, does whatever it is that they do. Does that make sense? It's a pretty straightforward architecture. Obviously, one of the other important components is called as a QoE server. It's a giant SQL database that hosts that all the Lync clients talk to. So the Lync clients send information about the call quality as perceived by them, right? If I'm making a call, my Lync client is going to send the information up to this box, and this box knows everything about everything that's going on from a Lync standpoint on the network. Active Directory plays an important role because Lync is very closely tied to the whole Microsoft productivity suite per se. It not only hosts who the users are, it also knows the Lync topology schema per se. So some of the ports that are being used, obviously Lync uses DNS-based DNS-SD for logging into, for one, finding where the Lync server is, and also logging into the Lync server. Some of the other common protocols that are being used in a Lync deployment, most of you might be aware of this, 5061 for any kind of Lync calls that are made within the corporate, within the corporate enterprise deployment, 5063 for any kind of audio-video conferencing. 443 is used by the Lync clients that are on the cloud, right, that are publicly hosted. Any kind of Lync online service uses 443 for any kind of signaling traffic. UDP ports are used for stunt traversal, so you don't need to have any kind of VPN or any kind of special services in place to avoid natting and all that, right? So it automatically does stunt traversal to check for connectivity, for media connectivity, and so on. UDP ports, the higher order UDP ports are used for the standard RTP traffic. So at the most fundamental level, how does this work? We talked about this briefly in some of the previous slides. When user establishes a Lync call to another device, all of us know how this works. Call setup happens via the Lync server, and all the RTP packets flow directly from one client to the other. Now, as soon as the call gets set up, the Lync server is going to send a bunch of information down to the Aruba mobility controller. And it does that using XML messages that are being sent via the API, right? It uses HTTP or HTTPS based on what your configuration is. Those messages are sent to the controller. The controller takes that information, and the first thing that it does is data path optimization, right? So Nabala is on a Lync voice call. So obviously mark those Lync voice packets with the appropriate DSCP setting. So obviously, as you can imagine, DSCP gets converted to WMM and so on and so forth as the packet traverses the different hops of the network. In addition to that, the controller also takes that information and puts it on the UCC dashboard that I'll walk you guys through in a minute. What that lets the admin do is to take a look at what is going on the network from a UCC standpoint. There are other interesting things that we do on a real-time basis that I'm going to talk about in a minute. So, as you can imagine, the data is also pushed up to Airwave. We use AMON feeds to push the data to Airwave to give you that historical, more network-wide aggregate visibility. So that was the call setup process, right? So obviously there are a couple of things that happens. As soon as the call is set up, the server is sending the controller information about the call type, the source MAC, the source IP, the caller, callee, destination, all the CDR level information that you can think of. It also sends the bandwidth level data. It sends you information about the codec that is being used. It sends you information about, it also kind of correlates other RF related information that the controller already has. What kind of client is it? Is it what is the PHY of the particular client? Is it 11A client, 11G client? What does its RF characteristics look like, and so on and so forth. Yeah.
Can you go back one slide? So this is downstream traffic, which is great visual. What about upstream traffic?
So it's a great question. So the question is, what happens for upstream traffic, right? Upstream traffic, we are dependent on the client devices themselves. Windows devices obviously have the capability to mark upstream traffic using GPO settings and so on, but most of the BYOD devices, iOS and Mac OS X and so on and so forth, does not have the capability. We do not have any control over it today. Now that being said, we are working closely with Microsoft to come up with a way. So if you remember, I talked about the applications programming the network. If there is a way, so as soon as the controller knows that there is Lync traffic on the network, and if we can build a mechanism by which the controller tells the Lync client themselves, irrespective of what kind of device it is, that, hey, by the way, you are on a Lync voice call, so mark all traffic with DSCP 46, right? And that way the devices, irrespective of what operating system it is able to mark traffic. So that's, again, these are things that we can potentially do with this model, given we are dynamically controlling the network.
Now, does the controller mark the traffic when it hits the AP or when it hits the controller? Because downstream traffic, right, it's all QoS, but upstream traffic, if the application doesn't mark, or if it does mark and the NIC doesn't honor it, it goes across
Right.
unprioritized, right?
Right.
So does it get prioritized at some point?
Yeah, so from a downstream standpoint, all the marking happens at the controller. And we take the DSAP value, throw it on the outer GRE header, and send it across to the access point. AP looks at the outer GRE header and converts that into WML. So your one leg of the call is complete. For the other leg, today, if I'm on a Lync call on an iOS device, there's no quality of service, right? So it comes to the access point. Now the AP can intelligently track the session for that particular client. It knows that this client A is making a call to client B, and it's on an iOS device, and it's a voice call. Now, given that it knows the session, it's able to take that session's intelligence and mark the traffic and send it up to the controller. Does that answer your question? But where we want to get to is what I talked about earlier, which is a mechanism by which the network can program the client devices.
What does it look like if you've got multiple controllers? Is this a broadcast message that's going out from the Lync server to multiple controllers in a group, or is this targeted based off of somehow knowing that the client is established on this AP with this controller and that I'm using that data?
That's a great question. So the SDN manager, the admin has to go to the SDN manager and punch in all the controller IP addresses today, right? The SDN API also has the capability to define the subnet range that each controller is using so that it can send the messages intelligently to the controller where the users are terminated. Now, obviously, not every deployment is going to conform to that kind of design. People might share VLANs and so on and so forth. In those cases, the controller, it's the onus is on the wireless LAN controller to take the SDN API message and forward it to the right local controller where the user is terminated. Does that answer your question?
Yep.
Okay, so we talked about the information that is being sent as soon as the user makes a call. There's a lot of other interesting things that we do when the user is on a call. One of those things is going to be the calculation of something called as a UCC score. According to us, we really wanted to come up with a metric by which we are able to calculate the quality of the call on a real-time basis, right? Because today, the Microsoft server sends us the MOS scores only post-call, after the call is terminated, which, by the way, is changing in one of the future SDN API versions. But there are a lot of other UCC applications as well where we don't have the benefit of having an API-based communication, right? So this UCC score is an Aruba proprietary metric that we calculate at the access point level. We basically do RTP analysis on the downstream traffic and come up with and look at what are all the transient parameters that could affect my current voice quality. And those parameters are defined on the ITU G107, basically delay, jitter, latency, packet loss, right? And we kind of come up with a metric, correlate that to the R value, the perfect R value, and tell you that this particular call has a UCC score of 70, for example, right? And it's a 0 to 100 scale, so 70 and above is good, 30 to 70 is fair, lesser than 30 is the call basically sucks. Now in the controller, we also have the capability to calculate every client's RF health that Sujatha talked about earlier. So this kind of gives us, as a wireless LAN infrastructure, for all the devices, all the BYOD devices, gives us a capability to kind of correlate what's really going on. Yeah.
You commented it's based on downstream traffic. So voice is a two-stream.
Correct.
And a lot of times, especially on Wi-Fi, you could have one-way speech, and it could be a variety of reasons, right? Right. So isn't that calculation skewed then?
It is. So it is skewed. So if you look at voice, the direction of traffic is completely it's relative to how you're looking at it from, right? Bidirectional traffic, if I'm making a call to you, on your access point, it is downstream. What my traffic is downstream. On my access point, whatever you're telling me, that media flow is downstream. So that was the first step towards the UCC score, but we are trying to see how we can kind of incorporate the upstream traffic as well. The similar kind of RTP analysis. So that's something that we are doing on the roadmap, but it's not there today.
Do you have any legacy stats from your previous wired voice deployment from a MOS score perspective, number of calls that drop below 80% or number of calls that dropped to an unacceptable level compared to what you have sort of agreed is acceptable level of subpar performance on the wireless infrastructure, right? Because that costs something, right? Your voice calls,
Right.
your MOS scores are in the 99.9%, really high, and then in the wireless space, you obviously have some that are below what's considered acceptable. As a trade-off, right? We all agree that mobility, the benefit of mobility is such that it's acceptable to have a reduced MOS score. Do you have something that you can compare previous to what you have today, and what that overall sacrifice is?
On the wireless LAN controller, no. Airwave is probably the best place to have that kind of a reporting analytics kind of a tool, which is something that we are looking into. Sujata, can Airwave track or compare MOS scores before, after kind of scenario? I don't believe we do that today, but you might probably know this better.
You're saying before, after?
Yeah, your deployment. So we have this. We've cut the wire. We moved over to wireless, right? What was our performance before we cut the wire? What's our performance afterwards? And can we compare those two together so that we can see what we're actually sacrificing from a call quality perspective across how many calls in our infrastructure?
Right.
So currently we are working on a report to give you an idea of how well the historical view of how the wireless network with Lync has been working. But that is not something that we are focusing on, but that's a good point where we could actually show you before and after numbers in terms of what's the improvement or not an improvement in terms of the quality, because not necessarily can it be, but good point.
Yeah. Okay, so in the interest of time, I'm going to jump in. So as soon as a call is over, we talked about what happens during the call. As soon as a call is terminated, the Microsoft server sends us information about the MOS score as reported by the Lync client itself, right? Now that MOS score is obviously end-to-end call quality. Its UCC score is something that we do on the Wi-Fi side only. MOS score is obviously something that's end-to-end that takes into account a lot of different metrics that could potentially bring it down. So we again take that information, we publish it on the UCC dashboard. With the next SDN API version that Microsoft is coming out with, they have enhanced it. So they're going to be sending in-call quality updates to the network endpoints. Now what that means is, in addition to the UCC score, we will also be having the MOS score as reported by the Lync client. Now that again opens it up to doing more correlation, better correlation. Because on a real-time basis, the controller is calculating this UCC score at the AP every few seconds. Now, every few seconds, we're also going to get the MOS score as reported by the Lync client. So there's a lot of interesting correlation that you can do to further provide more visibility.
And that's directly on the controller that you can see that UCC dashboard, and then further data when you get into Airwave.
So for deployments, if you remember, I mentioned that the admin has to go to the SDN manager and type in the IP addresses of all the controllers, right? Now that SDN manager can scale, today it can scale to 120 controllers. Obviously, certain deployments it might not scale. If you do not have an on-prem Lync deployment, if you have a Lync online deployment, like you don't have the option of doing SDN. If you're using IAPs, instant access points, or controller-less platform today, obviously there is an architectural challenge with respect to propagating the SDN API messages to the distributed access points that you have at the access layer, right? So those are the cases where Lync Heuristics comes in. Heuristics is an intelligence that we have built in on the controller platform. It's basically looking for any kind of transaction to port TCP 5061 from any client, which basically means which basically means the client is trying to make a Lync call. We do DPI, look at the RTP payload. We know how a Lync voice, Lync video payload looks like. We match it. If it matches, then we basically say there is Lync voice and Lync video. There are obviously going to be a lot of trade-offs from a visibility standpoint, because it's not like getting the information directly from the Lync server, right? It's something that we have, it's an intelligence that we have built in. From a quality of service standpoint, you are still able to prioritize Lync voice, you're still able to prioritize Lync video. We can't do much with desktop sharing and file sharing in this approach. Like I mentioned earlier, the key components that customers have to know or care about with respect to integrating the UCC infrastructure and the Lync infrastructure is the Lync front-end server that has the LDL and the SDN manager that I talked about earlier, right? Typically in a large deployment, Microsoft recommends to have multiple clusters of these Lync front-end servers based on geographies. And you typically have one SDN manager per Lync front-end cluster. That SDN manager talks to all the local controllers that are basically local to that particular geography, right?
I do have one quick question.
Sure.
Bugging me a little bit. Whose idea is it to mark all of your Lync traffic DSCP56? Is that Microsoft's recommendation, or is that something you guys are doing on your own?
Great question. It's been a question that we've been hearing a lot. So 56 is something that we have been marking on our own. That's been our default DSCP value for voice for a very, very long time. That being said, it's a configurable value that admins can go and change based on what your wired network QoS tags are.
Okay, so by default then, does your wired network switching infrastructure support DSCP56 in the same priority queue as 46?
Correct, yes.
Okay, just wanted to clarify.
So there's a lot of ongoing discussion going on today because some of the other major Lync themselves, their recommendation is to mark EF46 for voice. So does all the major wired infrastructure vendors out there today, Juniper, Cisco, everybody. So there's an ongoing discussion around should we change the defaults or should we make a big fat note or warning saying check your wired network QoS tags.